So we have x times y equal to 0. The first one, for all x and for all y, is p of x true or false? For all x and for all y. Okay, Sultan says false. Anyone else? Ali Habib says false. Others? Firas says false. Why? Why? Can someone give me an example of two numbers where it is false? Can someone give an example? Very good. Very good. Okay, very good. 1 comma 1. 1 into 1 is not 0. 1 into 2 is not 0. 2 into 3 is not 0. So this can never be true for all. It can never be. So this is clearly a false. Okay, let's look at another example. For all x, there exists at least one y where p of y is true. Is this true? Very good, Hussam. For which value of y, Hussam? Hussam. For which value? Very good, Hussam. Okay, you can take any value of x. X can be 3, x can be 7, x can be 9. Very good, Ali Habib. X can be anything. There exists at least one y, which is for which this is. So this is true. Okay, let's take another example. There exists at least one x for which all of y. Is this true or false? Ali Habib says true. Hassam says true. Firas says true. Very good, Sultan. For x equal to 0, there is at least one x for which all of y will satisfy this expression. So if you have x is 0, y can be anything. Y can be 7, y can be 8, y can be minus 11. For all y, if x is 0, it satisfies. So this is also true. Okay, one more. For some x, there is some y for which this is expression. Is this true or false? For some x, there is some y. Very good. This is also true. Why? Because for some x, it could be 0. There exists some y. So you can have many examples here. So for some x, there is some y. So for 0, 7, it satisfies. There is some x for which there is some y. So it satisfies it for this case. So this is also true. Very good. Okay, is this slide clear? Order is important. The order is important. The way you read it, it changes the expression. The order is important. For some, for all is important. So it's very important you read it very carefully. Okay, let's take another example. Another very, very simple example. The example on slide 46. Example slide 46. So the domain is given. The domain of x is given as 1, 2, 3. This is the domain that is given. Only 3 numbers. Okay. Also, some values are given. It says it's true for p1, 3. It is true. For p2, 1, it is true. For p2, 2, it is true. For p3, 1, it is true. For p3, 2, it is true. And p3, 3, it is true. For all the other values, it is false. Now the question is, now for all x, there exists at least, for all y, for all y there exists at least one x for which x is not equal to y and p of x comma y. Okay, now we want to know whether it's true or false. How should we proceed? How should we proceed? Clearly, we cannot just stare at the question and solve this. Okay, so what I do is, you might do it in a different way. What I do is, I break it up. Now, for all y, I have for all y. So y can take how many values? How many values can y take? For all y. So yes, it can take 3 values. So let's look at y. Okay, I have y. Y can take 3 values. It could take 1, it could take 2, it could take 3. And then we have x. How many values can x take? Again 3 values. So we have 1, 2 and 3, 2 and 3, 1, 2 and 3. Okay, so I have written this now. Now let's evaluate. So 1 comma 1, 1 comma 1, is it true or false? 1 comma 1. Ali Habib. Okay, I'm reading wrong, so I have to read x first, then y. So 1 comma 1 is false. 2 comma 1 is true. I have to read the x first. We have p2 comma 1, so it is true. 3 comma 1 is true. 1 comma 2 is false. 2 comma 2 is true. 3 comma 2 is true. 1 comma 3 is true. 2 comma 3 is false. 3 comma 3 is true. Okay, so I just write down what is given in the question. I have to read x first, then y. So 1 1 2 1 3 1, then 2 2 2 3 2, then 1 3 2 3 3 3. I've written this. Now let's go back to the question. For all y, that means in the first row, in the second row, and in the third row. For all y, I should have at least one x where x is not equal to y. So let's eliminate x equal to y. So this is x equal to y, we should not consider. X equal to y, we don't consider this. And x equal to y, we don't consider this. Okay, so only we consider cases when x is not equal to y. And p x comma y is true. Okay, so both this should be true and this should be true. So we need at least one x for all y. So for y1, do we have at least one x for which this is true? Yes. Okay, for 1 we have. For 2, do we have at least one x for which the expression is true? Yes, it's true for this. And here it's true for this. Okay. Now for 3, do we have at least one x for which this is true? Very good. So we have it true for this. Okay, so which means for y1, y2, y3, for all y's, we have at least one x for which this is true. Is this clear? So this is my way of doing it. You might have an easy way. So if I change this, to for all y, there is for all x, this is true. Is it true? If I change it, no, it's not true, because see, for y equal to 2 it's not, for y3 it's not. Very good, Ali Habib Muhammad Ali. Okay, so it is false. So there are two more examples given on the slides. I want you to go through those examples and try to solve them in the same way. And if there is a better way, come up with it. Okay, so I will wait for you to solve it. I'll just erase this. Please try to solve it. Fill up a similar table and do it. I can do it, but if I do it, you will not understand. You will understand better if you do it and you make mistakes. So I request you to please do it yourself. And if someone volunteers to do it on the board, I'll be more than happy to allow him to do it on the board. If you have a pencil that you can use on the whiteboard. This is the problem with Blackboard. I cannot erase only portions. I have to erase everything. If anyone has completed it on their sheet, you can share it. You can let me know, raise your hand, and I will give you permission to share it. So here the question is for all x. So again, x not equal to y. So we eliminate this case, eliminate this case, eliminate this case. So let's write the truth values. 1, 2 is false. 1, 3 is true. 2, 1 is true. 2, 3 is false. 3, 1 is true. 3, 2 is true. So we have this. So this has to be true, and this has to be false. Okay, p of xy has to be false for this to be true. So for all x, there is at least one y for which it is false. So it's true in this case. For 2 also it is true. But for 3, both values are true. We need at least one false. So because this expression should be true for all x, and it is not true for x equal to 3. So we say this expression is false. Is that clear? Very similar to the previous one, but here you have to evaluate this as false. This should be false. P of xy should be false for this to be true. For this to be true, P of xy should be false. So P of xy is false in the case of 1 comma 2, so satisfied, and P of xy should be false in the case of 2, which is 3, 2 comma 3, satisfied. But for the third one, we don't have any case, so it's not satisfied, which means it is false. Okay, try to do C also on page 46. Try to get it done, and that's the best way to learn. And we will stop with this for now. Okay, I'll stop the recording.